Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to start with Chapter 3, talking about congruent figures. And in order to really get a good hand on congruent figures, I want to make sure that you guys understand the difference between similar figures and congruent figures. So similar figures are figures that have the same shape, but different sizes. Their corresponding angles are congruent, and their corresponding sides are proportional. And their symbol, as you can see here, is just a little squiggly line. That's similar, okay? Congruent, it's very close to similar, but extremely different. Congruent figures, they do have the same shape, but they also have the exact same size, hence they're congruent. That means that all corresponding angles are also congruent. Corresponding sides are congruent. And the symbol is an equal sign with the similarity symbol. It's an equal sign with a little squiggly line on top of it. A couple things to remember throughout the rest of geometry. We're going to be seeing these symbols in questions and quiz questions and test questions and homework questions. First of all, when you have an arrow, a double arrow actually, but that's only pointing one way, it stands for implies. It's an if-then statement. And that means that it implies something. Okay? Angles that are right angles are both congruent. So if I tell you that two angles are right angles, that implies that they are congruent. If I give you a double arrow with arrowheads on both sides here, you can see here, both sides, that stands for the statement is reversible. I misspelled statement, I apologize. Okay? So, let's get to the important and the fun part here. Recognizing corresponding parts. I'm going to tell you from the beginning, and I'm going to try to repeat it as much as I can. You never go by the figure. When you are recognizing corresponding parts, you never go by the figure. You always go by the letters that they give you. You never go by the figure. In this particular case, you're going to look at what we're going to do, and you're going to say, Mr. Morrow, come on. I can go by the figure. Yes, you can in this particular case. But I'm going to invert the shapes. I'm going to rotate the shapes. I'm going to reflect the shapes. And you can never go by the figure, please. So, let's talk about corresponding sides and corresponding angles. This is how you recognize them. Okay, let me erase this. So this could be a little bit easier for us. Okay, so how we recognize them. The corresponding sides. See how you have AB here? The first two letters? Well, look at the first two letters on the other triangle. So AB corresponds to DE. I've proven that for you on the figure that we gave you because AB is congruent to DE. But you never go by the figures, ever. Okay? Ever. Yes, sir. No, that little line, the tick mark. No, it's just an arrow. I'm just saying that AB corresponds to DE. Thank you, sir. Okay, next. Do you see how I have, let me get the right color here. Okay. BC are the next two letters, right? And that corresponds to EF, because those are the next two letters. So BC will correspond to EF. And I've proven it on the figure that I've given you because both have 3 tick marks. And last but not least, I have an A at the front and a C at the end. And then I have a D at the front and an F at the end. So that means that AC corresponds to DF. And I have proven that for you because I have 2 tick marks on AC and 2 tick marks on DF. Yes, sir. Yes, you do have to put the line segment on top, but I'm just trying to be quick. But yes, sir, you absolutely do. I apologize. Thank you. Now, pretty simple, right?
Yep.
Okay, it's very simple as long as you follow the letters, not the figure. Please, guys, please don't follow the figures, ever. Okay, corresponding angles, same thing, but even easier. A corresponds to D. Okay, so angle A corresponds to angle D. And actually, these are all congruent because they're congruent triangles. B corresponds to E. And C corresponds to angle F. Okay? Does that make sense? Yes, no, maybe kind of, sort of? Okay. Now, since these are congruent triangles, all of these corresponding sides and angles are also congruent. So really, technically, I should have put a congruent symbol on all of these. Okay? On all of them. Because if two triangles are congruent, or any two figures are congruent, then that means that the corresponding sides are congruent and the corresponding angles are congruent. Pretty simple, right? Very powerful stuff, guys, believe it or not. So corresponding polygons again, all pairs of corresponding parts are congruent, and that's reversible. So you can say if two polygons are congruent, then all the pairs of corresponding parts are congruent. Now, let's talk about reflection and the reflexive property. Very, very important, like one of the most important properties we're going to learn. If you notice below, okay, you have two triangles. You have KET and KIT. And these are both reflections over the y-axis. So if I draw a red line here, KET and KIT are reflections of each other. That just means that I flipped it over. Okay? If I were to fold this over each other, every single point of KET will correspond to every single point of KIT. Think of when you were making your mom a little heart for Mother's Day, and you would cut out a heart. You wouldn't cut a heart out because it'd come out all weird, right? Because unless you were a super great artist. So what would you do? You'd fold the paper, you draw one half of the heart, you cut through it, and then you unfold it. That's a reflection right there. And the reflexive property postulate states the following. Any segment or angle is always congruent to itself. So what does that mean? What segment do triangles KET and KIT have in common? What segment, guys? Look at your notes. What segment does KET and KIT have in common? What do they share? Yes, sir. KT. Very good. So if we were trying to prove that these two triangles were congruent, one of the steps would be that KT is congruent to itself. KT is congruent to KT. KT belongs to KET and KT belongs to KIT, and that's going to help determine and or prove that KET is congruent to KIT. Does that make sense, guys? So reflexive property. Any segment or angle is always congruent to itself. Okay. Consider the following statement. EGD is congruent to triangle EHF. Notice that angle HEF and GED are simply different names for the same angle. So if we wanted to, by the reflexive property, we know that angle E is congruent to angle E. So that means that angle HEF is congruent to angle GED. It's shared by both triangles. Now, let's see if you guys are learning about corresponding sides and corresponding angles. Be honest. Is this as easy to determine corresponding sides and angles by looking at the figure? Be honest with yourselves. No, it isn't. Not even for me, guys, and I know how to do it, but who cares what I know? I'm always going to stick to what I taught you. So let's look at the corresponding sides and corresponding angles. EG is congruent to EH. Not because I say so, but because that's the first two letters. So EG is congruent to EH. Okay? GD is congruent to HF. And last but not least, we'll do it in a different color so you can see it. ED is congruent to EF. So ED is congruent to EF. Okay? Does that make sense, boys? Awesome. Now, we already talked about angle E, but besides just talking about it, we can prove it when we're looking at the corresponding angles. E is congruent to E. Why? Because that's what the letters tell me, man. So angle E is congruent to angle E. G is congruent to angle H. Angle G is congruent to angle H. And angle D is congruent to angle F. So please really understand and learn these skills, guys, because it's going to be really important. And oh, by the way, sorry, this is another example of the reflexive property, which we already discussed. Why is it the reflexive property? Because of angle E. Angle E is shared by both EGD and EHF. So you see how powerful the reflexive property can be, right? Okay, I'll take that as a yes. Okay, next, consider the following statement. What if I tell you that ABCDE is congruent to FGHIJ? You can sometimes conclude that this is true if you just slide the figure. Before we already saw a reflection. But if I slide this guy over here, they will match up perfectly. So sometimes I can prove congruency with a slide. We already proved congruency with a reflection. Sometimes the correspondence is evidence if we slide one polygon onto the other. Consider the following statement. Let's say that triangles FGH is congruent to triangle LKH. Okay? In this particular case, what angle is congruent to what angle? Angle 1 is going to be congruent to angle 2. Not only because they're vertical, but if you think about it, FGH and LKH have the H in common. So the reflexive property would be initiated there. Now, it's going to be very difficult for me to rotate this one. I tried to do it when I was creating the PDF. So it's not really going to help you too much. But basically what's happening is I'm rotating it on top of it. Okay? That was horrible, I know. But try to visualize it a little bit better than I could draw it there. Okay? It's hard for me to do it with this program. But I'm basically just moving it on top of it by rotating on point H. Okay? So we already have congruence correspondence to parts with reflections, with slides, and sometimes the correspondence is evidence if we rotate one triangle or polygon onto the other. Okay? And now that we've talked about reflection and rotation, it's not in your book, But I think that this is very, very important. You're going to see this from time to time, and I want you to be prepared. There are formulas for reflections and rotations. So I'm going to give you the formulas. If you have a reflection over the x-axis, okay, and the original point is xy, your reflection point will be x negative y. So whatever the xy was, multiply the y by a negative, and you have your new reflected point. You can investigate this formula with the first example that I gave you earlier today, where we reflected triangle KIT and KET. If you reflect over the y-axis, my original point is xy, you simply multiply the x by a negative. So it would be negative x comma y. Rotation formulas. If I have a 180-degree rotation, okay, a 180-degree rotation, my original point is xy, my rotation point will be negative x comma negative y. I simply multiply both x and y by a negative 1. If I have a 90-degree clockwise rotation, my original point is xy, my rotation point will be, oh, boo, boo, that's wrong, that's wrong, that's wrong. Who made this? This is horrible. Sorry, guys. It will be y comma negative x. My bad. Sorry. So what happens is the y value gets replaced with where the x value was, and the x goes to where the y was, but I have to multiply it by a negative. Why? Because that's what it is. Because do it. Try it on your own. Try a rotation or a clockwise 90-degree rotation. Not right now. Go investigate it at home, and you'll see every time that is the formula. And then if I rotate 9 degrees counterclockwise, and my original point is xy, my new rotated point counterclockwise will be negative y comma x. So I switch the x and the y's again, but this time I multiply the y by a negative, and I leave the x the same, but in the y's place. Okay? So trust me, knowing these formulas is a lot better than trying to calculate them on a test or a quiz or on an SAT. So know them really, really well. Live it, love it, and learn it. All right. Now, let's continue. If I tell you that M and N are midpoints, okay, and so that means that DC is going to be congruent to MC, correct? But I also tell you that, I'm sorry, that DM is congruent to MC. But I also tell you that DC is congruent to AB. Well, then that means that this, so actually let me not go ahead of myself because I'm giving you too many answers. M and N are midpoints. That's a given. Then I also give you that DC, this whole thing, is congruent to AB, which is this whole thing. Then I tell you that AB is also congruent to DB, okay? So that means that this guy's congruent as well. And then I tell you that angle 1 is congruent to angle 2, and that angle 3 is congruent to angle 4. I want to see some conclusions from this. What, or how rather, can you conclude that ADC is congruent to ABC? Anybody? Yes, sir. No. Why would it be reflection property? No. Think about this, guys. All right. I'm a little bit sad. Come on, guys. Didn't we say that angle 1 is congruent to angle 2? Right? And angle 3 is congruent to angle 4. Correct? Okay. Thank you very much. So we're going to be talking about angle addition property. How can I tell that CM is congruent to AN? How can I tell that CM is congruent to AN? Yes, sir. No. Don't I have a double midpoint here? Okay. If M is the midpoint and N is the midpoint, that means that DM is congruent to MC and AN is congruent to NB. So that means that CM will be congruent to AN. That is going to be a division property. Yes, sir. Okay. How would BD be congruent to DB? Okay, it's not an angle, but okay. Reflexive property. Isn't BD the same as DB? Then we just talk about the reflexive property that angles or segments are congruent to themselves. And then how can I say that DC is congruent to DB? Transitive property. Very good. Excellent. Excellent. Well played, my friends. Well played. Okay. Let's try another one. FP and GP are angle bisectors. Angle bisectors. Angle bisectors. There's a double bisector. Angle 5 is an acute angle. Angle 5 is congruent to angle 7. PF is congruent to PG. And QG is congruent to FR. How can I conclude that QFG is congruent to RGF? No, it won't be addition because I have a double bisector. Think, guys. I tell you that FP and GP bisect or are angle bisectors. So that means that these two get cut into equal angles, and these two get cut into equal angles. But didn't I tell you that angle 5 is congruent to angle 7? Guys? Okay, so now I'm going from small to large. QFG is congruent to RGF because of multiplication property. How and why are QP congruent to PR? Let's think about that. I tell you here that, very good, subtraction property. I tell you that PF is congruent to PG, right? But I also tell you that QG, this whole thing, is congruent to RF. So if this little piece is congruent to that little piece, how can I tell that QP is congruent to PR? Subtraction property. Because when I subtract congruent segments from congruent segments, their differences are congruent. How on earth is angle 7 an acute angle? Not assumed. You never assume that. Substitution. Didn't we say that angle 5 was an acute angle? Doesn't that mean that it's 90 degrees? That means that we're talking about values. So that would be a substitution property. And last but not least, how can we prove or conclude that FER is congruent to GEQ? Reflexive property. Very, very good. Because E is the shared angle. That's exactly correct. And we are done. I hope you learned a lot, guys. Complete your homework. Thank you for a great class as always, and have a wonderful day.